Hi, it's Mrs. Pope, and today we're going to talk about systems of equations with matrices. We're going to actually lay all the foundation work on the video for how to solve systems of equations, but when we actually solve them, we're going to do that in class. So, goal, we want to find the inverse of a 2 by 2 matrix and use to solve a system. We're going to verify inverse matrices. So like I said, we're not actually going to solve the entire system, we're just going to lay the foundation. So here we have the identity matrix. What an identity matrix is it's a square matrix that when multiplied by another matrix, it equals that same matrix. Well, we use identities all the time. In multiplication, the identity is 1. Anything times 1 is itself. In addition, the identity is 0. Anything plus 0 is itself. So in matrices, it's called an identity matrix. When you multiply a matrix by this, you get the same matrix. So a 2 by 2 identity matrix has two ones on the diagonal, and the other places are filled in with zeros. A 3 by 3 identity matrix has 3 ones down the diagonal and zeros everywhere else. A little bit of vocab. Inverses, as far as matrices are concerned, 2 matrices are inverses if their product is the identity matrix. So if you multiply 2 matrices together and you come up with one of these, then you can quickly tell and know that they are inverses. All right, let's verify inverse matrices. So let's determine whether A and B are inverses. So from the definition, if we multiply these, then we should be able to tell if they're inverses, if they come out as the identity. So if I take, this is my new AB. So remember, we take -4 and the 2 and we flip it. So this is 4 times the 4th plus 2 times the half, right? And then the 4 and the -4 and the 2 times the -1/2 and the -1. So -4 times -1/2 plus, let's make this bigger, -4 plus 2 times -1. And I'm not going to write out each one, but that'll just jog your memory of how we calculate when we're multiplying matrices. So, if we do all of these and you multiply the bottom times the left and get the bottom left, the bottom times the right and get the bottom right, you'll see that your final answer is they're all zeros. So this is not, these two are not inverses because when you multiply them, you don't get the identity. So not inverses. Had we gotten the identity, they would have been. All right, example 2. Find the inverse of a 2 by 2 matrix. So this is actually figuring out what the inverse is. We know how to verify, multiply and see if they get the identity. And in order to find the inverse, we have to use this. So here's the key concept. If P is A, B, C, D, then the inverse, that's P to the -1, the inverse is 1 over AD minus BC times what I call the mixed up matrix. So if you notice, A and D have flipped positions. A went where D was, D went where A is. B and C stay in their same position, but we negate them. So it's -B and -C. So let's see how this works. Here's our P. If I want the inverse of P, I'm going to take 1 over AD, so 7 times -1 minus BC, -5 times 2 times the mixed up matrix. A and D switch, so this becomes -1, this becomes 7, and negate B and C. So this -5 becomes +5, and this +2 becomes -2. It might seem like a lot, but it's really not that bad. So if we simplify the bottom, we have 1 over -7 minus -10, which means +10. So -7 plus 10 is 3. So we have 1/3 times -1, 5, -2, and 7. So finally, if we multiply, distribute that, this is just like a scalar, so we're going to multiply. 1/3 times -1, so we end up with -1/3. And then we end up with 5/3. Then we end up with -2/3. Then we end up with 7/3. So this is the inverse matrix of our original matrix P. You should know if you multiply them, you should end up with the identity. Maybe you should try that. All right, thanks for watching, and remember, you are responsible for your own learning.